This is question 3 of the 2019 Leaving Cert Higher Level Paper 1. Now, I'll have it in the description below the question, but hopefully you have it in front of yourself already if you're coming to look at this video. But the gist of it is here on the board. It's factorised. It says factorise fully. 3xy minus 9x plus 4y minus 12. So factorising these can often be tricky because you can get multiple middle parts to the question. You can do it different ways. You can look at your friends, how their solution, and it could look different. But the answer should, if done correctly, be the same. So be warned about that. The gist is we take two of these terms, any two really, and we take similar things out of both of them. In this case, I'll just take the first two terms and we'll say what's similar in both of them. There's a 3 in both of them. 3 here and a 3 times 3 for the 9. There's an x in both of them. So let's go ahead and take 3x out of it. So 3x multiplied by y would make this. Multiplied by minus 3, just minus 3 would make this. So we go ahead and do that. Now we're looking for this, the thing we took out, what was left over in the rest of it. So the next two terms, is there a y minus 3? That's what we're looking for. You can keep an eye out for that, but you don't have to fully do it that way. You can also just say what goes into both of these and hope they match up. We'll try and make them match up. And in this case it does. If 4 goes into both of them. 4 goes into this y, 4 goes into this minus 3. And we have similar things. So that will happen in multiple different ways. I'll do the question again, in fact, a slightly different way when I finish. Because I'm just finished. 3 minus y minus 3. Y minus 3 is in both of these. So let's take that out. Because this now just becomes two terms. Two big terms. Y minus 3 goes into this 3x times. And it goes into this 4 times. That's it. Factorise fully. That's our full solution. Let me rub this out and just do it a slightly different way. Let's pick two other terms. Let's go with this term and this term. And let's see what we can get out of that. Y comes out of both of them. So how about we get y here, 3x and plus 4. And how about the two terms that are left, this one and this one? We can take minus 3 out of both of them. Well, minus 3 if you notice. So there's a minus 3 in this. And there's a minus 3 in this. So minus 3 out of this would leave 3x's. Minus 3 out of this would leave plus 4. Again, look, we have the same, well not the same one, but we got two things the same, two brackets the same. So you could have done this in multiple ways. First and the third, first and the last, second and the fourth, third and the fourth. Well, yeah, we could have. We could have got a 3 would have come out of all these. This 3 here, probably. So let me finish it this way. 3x plus 4 is in both of them. There's a y in this one and there's a minus 3 in this one. And again, we have the same answer as we had before. So that is it fully factorised. Let me move on to part B. Okay, part B can be seen up here. 3x natural log of x minus 9x plus 4 natural log of x minus 12. And it says that's gx is equal to that. And then it says gx equals 0. So I've just put it equals 0 here to save me a bit of room. Now, but it also gives a nice hint. It says to use the answer from the first part. So I've left the answer here from the first part. Here was the question. Here was it fully factorised. And now the reason they hint that is because this is very similar to this. The only difference between these two lines is y is equal to natural log x. If I replace y with natural log x, they'll be the same. So if this line is the same as this, its factorization should be the same. So to go ahead and factorize this would be the same as this answer. It would be 3x plus 4, be a minus 3 here. The only difference would be the y. I would get natural log x. That's the only difference. So we're nearly finished. We can write the answer out straight away. And this becomes, x is equal minus 4 over 3. That's 3x equals 4. 3x equals minus 4, and divide both by 3, we get this. And this one becomes natural log x equals 3. Two answers. We can go ahead and give them more exact. Did they ask for any? How exact do they ask? This is probably fine. Minus 4 over 3. It doesn't ask for any decimal places. So if we solve this, we take both sides, put both sides over the power of e. Is that how I say that? I'm not sure. I'm always stumbling how to say that correctly. But e to the power of natural log will destroy each other. So we're just left with x is equal e to the power of 3. E3. And that's fine. If the question didn't ask us for any decimal places, this is an exact answer. This is fine. This is an exact answer. This is fine. But if they ask you for decimal places, you'd have to put this in on a calculator. Right, let's have a look at part 3. And of course, by part 3, I meant part C. So part C says, evaluate G prime E. So they're first of all asking you, what does that mean? That's your first question in this case. That's the derivative. That is the derivative of G. And also that is when x equals E. So the derivative of G when x equals E. So from the previous part, gx is equal to this. So they're first of all asking us to find g prime x, the derivative of g. That's the first thing we need to do. So let's go ahead and try that. We have 3x multiplied by natural log x. Both of these things are in x. That means to get the derivative of them, we need to be careful. We need to use the product rule. Neither of these are constants. Both of them are moving. As x moves, both of these move. So we need to go ahead and use the product rule. I'll write the product rule here. When we have two things multiplying, u times v, when we have two things multiplying, when we have two things multiplying, the derivative, let me write this fx here. Fx equals uv, and the derivative of f is equal to u v prime plus v u prime. Sometimes you see that the other way around, I just remember it that way. So we have two things multiplying. So the answer, the derivative of these, is the first one left alone, 3x, multiplied by the derivative of the second. Go ahead, look in your formula tables, depending on where you are in the world. If you're maybe not doing a leaving cert, you should be given, you're probably given rules how to differentiate this, or maybe you've just memorized it yourself. But the derivative of natural log x is 1 over x. So that's u v prime plus v, that's natural log x, and the derivative of this, and that's 3. Let's be careful when we're multiplying by 3. It can get confused. If you don't want the 3 to become inside the natural log is only the x. This 3 we can write out front if we're a bit more careful. Okay, let's continue on. We're still differentiating. We get minus 9x. That's easy to differentiate. That just becomes 9. There's no natural log or anything. Sorry, there's no product rule or chain rule or anything. Again, this becomes easy. Plus 4. 4 is just a constant. We can ignore that till after we differentiate. Natural log x. Again, that's a rule how to differentiate. We can look that up in our formulas. 1 over x minus 12, that's just 0. So this is it, differentiate. Let's clean this up a little bit. We get 3x divided by x is 3. We get plus 3 natural log x, and we get minus 9 and plus 4 over x. That is the derivative. You've got yourself some marks there. To get yourself full marks, they want you to put in evaluate when e goes into it. Well, this just becomes 3 plus 3 natural log of e. That destroys itself, and we're just left with the 3 minus 9 plus 4 over e. Let's clean this up. We get 3 plus 3 minus 9 is 6 minus 9. It's minus 3 plus 4 over e. That is the exact answer, but they didn't want the exact answer. They asked it for correct to 2 decimal places. So to do that, we just get our calculator and type this in. We have minus 3 plus, I like to put a big brackets around when I'm doing big things with calculators. I like the calculator not to get confused. I'm not the best with it. So I put a nice brackets in, and then 4 divided by e. Where is my e? Here it is here. Oh, I have to put e to the power of 1 on my calculator. I don't think everybody's calculator will have to do that. I think there's probably a button just for E on some people's. Either way, I have it here. The answer is minus 1.52848. Continues on, but they only wanted 2 decimal places, so minus 1.53. It's closer to 3 than 2. Right, that is part C of question 3. If you have any questions, let me know in the comments below. Our next video will be question 4. Hopefully see you there for that. Until then, have a good one. Bye.